Hi everyone, welcome to another Wolfram Language Design Review for version 15. Let's see. Let's jump into...
You're not sharing it?
I'm not sharing. Oh my gosh. Let's see. It's really weird. Okay. Hold on. Now it should be.
Yep.
Okay.
So these are some small updates that you saw a month ago about all these functions.
How does it work for Jupiter? Does that mean anything for Jupiter?
Well, we can compute the night hemisphere in Jupiter.
I guess we can, you're right. It's just not affixed there.
Right. There are examples further down in the agenda notebook. I don't think we have added examples here yet.
Sorry, where are they from?
Yes. Open these subsections, like the first one.
Night hemisphere, friends take.
Yeah, exactly. So this is an example of showing what the Apollo astronauts saw for the first time from the moon.
What is subpoint again?
Subpoint is the point of the Earth that has something exactly at the zenith, exactly above. And so in this case, we are selecting the point of the Earth that has the Apollo 11 landing site exactly above. So if we look from the Apollo landing site, we can center at that point of the Earth.
I see, going to the center of the Earth. So you line from that point to the center of the Earth. This is where it intersects.
Exactly.
Right?
Exactly. So in this way, we can get the orientation of anybody in the solar system.
Actually, it's not quite to the center of the Earth, right, Jose? It's well, is it? Yeah.
Well, it's almost the center of the Earth.
Yeah, almost the center of the Earth.
Why
modulo
is this
ellipticity
thing this way round and this one this way round? Why is it not tipped that way, or did they tip the camera?
Well, this is a matter of us rotating our result, which is another option that I will describe further down. We are working on that.
But they were standing on the ground and looking up, and the Earth was tipped that way for them.
Correct.
Yes, but they may have rotated their camera. That we don't know. I mean, what we can do now is to rotate our result heuristically until we match.
I mean, surely we know if when they planted their feet on the ground, they look up in the sky. I mean, it's just like the moon can be tipped at different angles.
Oh, I see what you mean. Then they would have seen what we are showing here. They rotated their camera. Exactly.
Oh.
Their camera is rotated.
Is it?
Yes.
Well, what part of the LEM is this?
I don't.
I assumed this was above the LEM, and so they're looking up, and that's what they see.
Well, but that's not what is being claimed here. This is being claimed relative.
No. That's because we're not rotating our view.
No. Sorry.
North is up.
Jeff is right. Yeah, exactly. So yes. So the north pole of the Earth is rotated. So geographics doesn't have information of that rotation. Astrographics would have that information, but geographics does not. Geographics is putting the north pole of the Earth above.
I see.
Yes.
But so if this was done with astrographics, presumably we can feed this through to astrographics, yes?
We could, exactly. That's something we should do, which is feeding the textures of other bodies to astrographics. We want to do that. We haven't done it yet, particularly for the moon. Rather than showing a gray disk, we want to show the actual surface of the moon.
Yes.
If we get close enough to the moon.
Okay, but what's new here is the night hemisphere. Well, this is of the Earth, which we already had.
Yeah, so this is another. So the new parts are in the previous two sections. So this is just a nice combination that Jeff managed to. So here we have, for example, the fact that we can show the civil, nautical, and astronomical twilight zones, which we couldn't before.
I see. That's nice.
This is a new option, reference altitude.
Why is it? Why? I mean, I understand that it is the reference altitude, but why is it not just? I mean,
so the definition of these things are 6 degrees. If you scroll down a little bit, there is a manipulate that will show nicer what's going on. If you, I guess you may have to evaluate oh, yeah. I saved the finisher. So now try to rotate this manipulate. So this shows the first one is half the Earth, and then the other three are the other twilight zones.
I understand, but where did reference altitude come from? Is that an option we already had?
We had it in sunrise, sunset, etc., to compute the times where the sun reaches those levels.
Okay.
Yeah. So now we can have these zones in which, I mean, the astronomical twilight is when the sky is dark enough.
Yeah, I understand. It's confusing me to say reference altitude here because it's like what's at that reference altitude?
Right. So those are values of the sun. So civil would be -6 degrees, nautical -12, astronomical -18. It's altitude
reference altitude of the sun.
Of the sun with respect to the horizon.
Okay. So long as that's explained, I get it.
Yep. And then now, I guess here, yes. So this is able to show the night hemisphere on the moon. So we can now show phases of the moon directly in geographics.
Right. Although I don't quite understand why. Oh, I see. It's just showing the rest of the moon just as the moon.
Exactly. And here we see this combined effect of the Earth, sorry, of the moon orbiting the Earth. And so it's getting farther away or closer together with the orientation with respect to the sun.
But this is geographics. Why does it know how far away the moon is?
Oh, because it's the, you see astro distance, plot range. The plot range is astro distance divided by a fixed amount. So we are simulating that. Again, in the future, astrographics should do this automatically once we can put this texture there.
Oh, this is very cool. Okay.
And so this is the same thing with Venus, which is even more impressive because Venus changes distance a lot more. And then we also see the rotation backwards in Venus.
We should be making little videos of these and posting them.
We will.
That is interesting.
We see how,
of course, if you turned on day hemisphere and made it solid white, you could reproduce what you actually see in a telescope. Here we're seeing the ground of Venus so that you can see the rotation. But of course, through a telescope, you would only see clouds.
Yeah. Right.
So, but you can simulate that too if you made the night side completely dark and the day side completely white.
Right, but when it comes to Jupiter, for example, all we show in the texture is obviously the clouds because we have no frigging idea what the surface, if there is one, is like.
Right. And also interestingly, because Venus is an interior planet, we see all the faces. For exterior planets, we always see mostly the whole thing illuminated all the time, except for a little bit of wobbling on the sides.
Mars shows some. You can get a gibbous Mars, but the further out you go, the less of it you see.
Well, you should make these pictures for all the various planets, make little videos. These are really nice.
Right. And we want this in astrographics itself.
Yes.
And then we would have also the orientation. For example, here, the bodies are always oriented vertically for the same reason we were discussing before.
Cool.
Okay, so this is another new thing, which is GeoAxis, the ability of showing latitudes and longitude numbers inside the map versus the projected coordinates, which particularly for the cylindrical projections has always been a bit confusing. For other projections,
I don't know what these are. What the heck are these?
Right, so those are called Mercator latitudes. And so the Mercator projection is actually a very, a long band projecting the poles to infinity. It's just that we are cutting at 85 degrees to make it square. But we should imagine this like progressing vertically to infinity.
Yes.
And so,
what if I want to put these scales on the outer frame?
Well, further down, we show that we can move them to anywhere, right? We can displace them to the side, but it will always try to be inside the map so that it doesn't collide with the other one. We should invent some way of
I don't understand what the use of the outer ones is.
well,
Well, sometimes you get measurements in those projected things, actually.
exactly. You want to work with either projection, with either coordinate system. Sometimes one, sometimes the other. For example, imagine that you have an arrow pointing from the outside of the map to the inside of the map to say
Yes.
this is something. That outside has to be, of course, in projected coordinates.
What do you mean?
Yes. So if you're going to go outside the map, the projected coordinates are still defined.
Oh, I see what you're saying. I see what
Right.
you're saying. Yeah, yeah.
But so we need both coordinate systems. It's a fundamental thing to understand both when working with geo. For example, here, right? So this square in the Peirce quincunxial projection is, I think it's from 0 to 1 in coordinates. So if you want to do something in projected coordinates, you need to work with those. While latitudes and longitudes are very weird here.
How did you decide how many axes to put in here?
Right. So the geogrid lines, it says every 10 degrees.
Okay.
And so
And then
that
where's-
determines the
yeah.
geogrid lines, and the geoaxis by default try to follow ticks along the geogrid lines.
Mm.
But you can also specify with the multiple options of geoaxis what to put.
And in typical map conventions, is the negative number right, or is it west or something like this?
I think negative numbers is I mean, you can find both things,
I
but
see.
negative numbers is the standard. And then this is an example of showing how geographics not only has support for geoaxis, but also for axis object itself. So we can convert now any geopath into an axis object and
That's
put
cool.
ticks along
Right.
it.
So that says if I go from here to wherever, this is where I'll get to if I'm at 2,000 miles, et cetera, et cetera, et cetera. That's very
Exactly.
nice.
Exactly.
So when are we getting geotrajectory, and how does this relate to that?
Yes. So there we will be able to put dates also, which is something that I want to do for astrographics as well, for orbits, etc. But yes, we're working on that. It's not for this release. Yeah.
Right.
So this is something which is under development. I'm afraid you cannot test it yet, but this is the sort of map that we want. So georotation will be another option following geoprojection, allowing a three-dimensional rotation, like we did in the last version for georeposition.
Yes.
And so you put there it accepts a bunch of possible notations for rotations, like a rotation itself, Euler angles, or a rotation saying move from here to another place.
But this here, oh,
Mhm.
I see. That's three.
3 Euler angles.
I see.
And it's the ability to define any arbitrary three-dimensional rotations, which requires 3 numbers.
Right. So you're rotating the globe before you do the projection. Is that the idea?
Exactly, yes. And then another option, geogrid rotation, will do a rotation around the center of the map, now in the projected space. And the
But
idea
it
is
still
to
leaves
keep
the map as a rectangle like this, or what is
it still as a rectangle, exactly. If it has
Okay.
to be cut because it's too much, then it will be cut. But typically, it's used for local maps. As if you scroll down a little bit,
Yeah.
people
Oh.
have requested multiple times that they want to orient, say, north in a different direction rather than up. For example, this map of New York is now it has north to one side, but you still want all the labels nicely horizontal.
And how does it know that it's projecting? I don't understand. The oblique Mercator has a
this-
different definition of north.
Yes. So oblique Mercator was the only projection we had before capable of doing this. Now what we will be adding with the option geogrid rotation will be this ability in every projection.
I see. It's nice.
And you will be able just to say a single angle, how much you want to rotate the map around the center.
Where are we at with having a 3D, with being able to do geographics 3D?
Yes, this has been suggested, and John McClune has a WFR to do that. But I think I want to first have full control on vertical datums, which we don't yet have. So we have full flexibility with horizontal datums, but not yet with vertical datums.
What do you
And-
mean
and-
vertical datum? You mean knowing what it means to be 10,000 meters above the surface, or what?
Exactly, knowing what zero means. Because if you say, oh, I am at elevation 0, it means different things for different people, because mean sea level is so deformed.
Sure.
And so this can vary by hundreds of meters.
But I mean, most of the time, people are going to want 3D. They're going to want something from a plane type thing. Well, I guess it might matter. I mean, from a plane, you're seeing 250 miles, give or take.
Right. Yes. So yes. So it will have two situations. One is some sort of local geographic 3D, and then the global, in which you see the globe, actually.
Mhm.
We may have two different functions for that because the situations are so different. Sometimes you want to take into account the curvature, sometimes you don't.
Be a nice thing to have.
Yes, it's in the plans. And then this is a very small thing, which is just the update of this projection to actually explain what it means three-dimensionally, in a sense. It's still projected 2D, but one understands the tube nature of this projection.
What the heck is it doing? It's like putting the world on a torus.
Exactly. Like half of it.
Why does that stick out?
Because we put the labels in the projected space. And if that happens, we don't avoid it. Yes. So the labels don't get curved. Okay. So then this is something you wanted to have a couple of years ago, but we didn't have the technology to do it. And now you have seen the ability to do it per location. And now here we have per location and for extended regions. And something I wanted to discuss in this meeting is the name of this new option. Because we used geolocation because it was an existing option there, but I don't think it's right. I think it would be better to have some sort of eclipse something name, like eclipse type. In a sense, this is restricting all the eclipses to those that cover this location.
Right.
And it detects umbral eclipses, meaning total, annular, and hybrid.
But don't we have an eclipse type option?
Exactly. One can combine this with eclipse goes to total, eclipse type goes to total. And yeah, so this, for example, is the next eclipse going through London. And then we can check with a map that the eclipse path of totality actually covers London.
Why don't we call it eclipse location instead of geolocation?
Yes, Jeff and I were wondering if it needs to have cover there to understand because solar eclipse also takes a location parameter to say I'm observing from. For example, you could say, what do I observe from Champaign for an eclipse that goes through New York?
So normally you give solar eclipse an eclipse entity,
Mhm.
and then it computes things about that eclipse, right?
Exactly. But there are local properties.
Oh,
You
no,
can
not an eclipse entity. Oh,
an eclipse date. Yeah,
date.
Right.
exactly.
But maybe what we want is something called find solar eclipse that gives you by default a list of solar eclipses consistent with some region, of space and time.
We could separate a function to do that, but I think it still would be nice to have it together with all the other freedoms of solar eclipse so that you can combine things.
Well,
but
isn't it a different operation? I mean, one thing is you've got a solar eclipse, one of
Mhm.
them. I mean,
Yes.
you're looking at its various properties. And another is you're finding many solar eclipses, which you
Mhm.
can then, after you say find solar eclipse and it gives you a bunch of eclipse entities, then you can map solar eclipse over those to conclude things about them. Or even it could return,
Jose, don't you have an example down below that shows multiple eclipses over a certain location?
Yes. So with this function, we can get, for example, all the eclipses in 30,000 years that go through Champaign. But of course, with solar eclipse, you can ask for a property. So you could say, give me this property of all those eclipses without having to go through this intermediate list, which will take several seconds to create.
Yeah, but once you have, I mean, yes, the list takes time to create, but shouldn't that be the job of Find Solar Eclipse?
Mhm.
This seems very different from going in and picking a particular eclipse here.
Again, we can have a separate function, but I would still like to have this playing with eclipse type. For example, how is this different from give me all the eclipses that are total? Right? We don't have a function find eclipses by type. It's a role of
No,
solar
I understand,
eclipse.
but why not say find, solar eclipse? Look, why don't do something like this? Say find location and time, and then eclipse type, arrow, blah, blah, blah.
We could do that. I mean, we would add the other options of solar eclipse to return the dates with various parameters. So
Right, but I claim the operation
Mhm.
finding solar eclipses is a different operation. How do we do that with syzygies of various kinds? Because isn't it
we have find astro event.
okay? Which could, in principle, find solar eclipses if I'm not
And it
mistaken.
does, exactly. Yeah. One of the types of events it finds is solar eclipses.
So it seems to me perfectly reasonable that we can have, find solar eclipse as a special case of find astro event.
Yes, and a particular case of solar eclipse too. Yeah. Mhm.
Well, except what I'm imagining is that solar eclipse is more a thing that takes a single solar eclipse designator and does things with it.
Mhm. Yes.
Just like find astro event. Let's see, it's just giving us dates. Is that right?
Yes. But it can be a list of lists too.
Mm-hmm.
Yeah. I mean, we can certainly have that function, which is some sort of intermediate between find astro event and solar eclipse.
I think so. I think that's what we want. I think it's confusing to have it be solar eclipse itself be the finder.
Okay. So this is the new thing, which is a bit more complicated computational geometry computation. And you give an entity or a geopolygon, and it's able to find all the eclipses that cover that intersect with that. And so, for example, that map there shows 3 eclipses going through Spain in the next 2 years or 3 years, which is unusual.
Mm-hmm.
And then the next one is all the eclipses through the US in the last 100 years.
Very cool.
And you see it takes like half a second to compute them.
Very cool. So, I mean,
I think the only thing missing would be what partial eclipses, Jose. Is that right? Still have
Yes,
to be
this
done.
is able to find so far umbral eclipses. Partial eclipses, there are so many and so large that I'm not sure it's useful, but we can extend it too.
Yeah.
Yeah, you can evaluate it. If you have a recent enough X-kernel, it should work. Let me have to download things.
So that's the next one.
The next umbral eclipse. So now that one might be total, annular, or hybrid. We don't know.
Okay. So now I would say, what happens if I want the next? So otherwise, I would give, we've got a number of functions that can take locations and times in any order, right?
Yes.
That's great.
So that's a map of all the eclipses in, I think, in 1,000 years going through Australia.
Wow. That's cool.
It's like a giant
Very cool.
spider
It is. Yeah.
or feathered star or something like that.
Very cool.
Mhm.
Interesting. Man.
Yeah, this is based on a combination of Boolean operations and tabular storing some pre-computed grid. Lots of data.
Nice.
Mhm.
Okay, orbital elements.
Yeah, so this is another new thing. This is the very beginning of the orbits project. And so this is a manipulate to explain the fundamental orbital elements. So to give an orbit, we need 8 numbers.
By
And
the way,
so-
you should use standard green, not green here.
We are working on this manipulate. It will change
Okay. I'm just saying,
substantially.
standard green looks better than green.
It's a curly pie. Yeah. Oh, so yes, so that's
Actually, I thought it was Omega. I don't know if it's
No,
curly pie
no,
or
no, it's-
Omega.
it's curly pie. It's and actually it's funny because the Wikipedia page says that curly pie is basically only used with orbital elements theory.
Yeah.
And so and we have to extend this manipulate also to cover elliptical and hyperbolic orbits. This is only ready so far for elliptic orbits. But our orbital elements can handle all of
We
them.
should be promoting this stuff to people who teach astronomy classes.
Absolutely.
Nice stuff. Okay.
Yeah, so the function so far is called orbital elements. And by default, it reports a selection of 8 numbers. There are many sets of 8 numbers that people have used over the years. And depending on what you are working with, like satellites around the Earth or bodies in the solar system, etc., there are different sets. So far we can compute of the order of 50 different objects.
Is this the 2-line elements list, or is that something different?
The 2-line elements contain this and a bit more information. It contains also information about the dragging by the atmosphere, things like that.
I see.
But our plan is to support a TLE, a 2-line element, as first argument of orbital elements, and then it will know what to do.
Yes.
The only problem there is that to propagate in time the information of TLEs, we need a special propagator called SG4, and we don't have that yet. But that will be added for 15. And then we will be able to handle very precisely, I mean, with errors of a kilometer at most, all the satellites around the Earth.
Cool. Is a kilometer the best anybody can do?
So the TLEs typically are good for a day or so. And if you are not careful, you can make already from 1 to 30 kilometers of error in a single day. With TLEs, you can decrease errors to below a kilometer.
I see.
Yeah.
Because you're using a propagator that knows how to deal with them.
Exactly.
Right.
Exactly.
Not just using it like a Keplerian, like you're in a vacuum type thing, but because TLEs consider atmospheric drag, you can model it essentially to
Exactly.
get better.
Exactly. And as Jeff was explaining before, with coronal mass ejections, events, etc., the atmosphere can change so much that things become rather unpredictable from one day to another.
So how do, for satellites, they can usually adjust their orbits. That means that they have,
Some can, not all of them.
right.
If they
a lot
fire
of
their
this,
thrusters, the
Yep.
TLE is garbage.
Exactly.
That was my question.
yeah,
Yep.
most don't have thrusters. Some don't. I think a lot of the Starlink ones don't have thrusters. I don't think they can.
I thought they had
I thought
to
they
have
had like
collision
coal
avoidance
gas
now.
thrusters.
Yeah, I thought they could have. They did collision avoidance these days.
Right.
That may be the case. I don't know for sure. I didn't think they did, but it's possible some do. I do know that
Yeah.
what was it, about a year or so ago, they lost like almost 60 of them because it was a CME that hit and they heated up the Earth's atmosphere, and it brought down a whole bunch of them because they got too much atmospheric drag because the atmosphere got heated up, expanded out further.
Hmm.
And maybe that just happened fast enough that if they did have thrusters, they couldn't compensate. I don't know.
Or maybe the thrusters can't move them that high. Maybe
Maybe
they can just make a small change to avoid a collision.
that could be too.
Exactly. Yeah. I think there's a huge difference between those two kinds of thrusters.
So orbital elements can handle currently anything in the solar system, including now comets and minor planets, etc. And that's an example of showing how the Earth is changing eccentricity quite fast, monthly, because of the pull from the moon. And if we compute the so-called EMB, Earth-Moon barycenter, then that's a lot more stable. So this
Well,
smooth curve,
These kinds of things, shouldn't they be entities? Shouldn't they be astro points of interest, like the Lagrange points and things in various
Right.
systems?
we
Should
have
surely
discussed
be-
that. Having in the same way that we have a geographic region, we have a generic geographic region entity domain. So we could have an astronomical something generic
we
thing.
both want region and we want points. Like we want the Lagrange points. We want these
Yes.
things like the Earth-Moon barycenter.
Exactly. We'll discuss that. Adding a new domain for these things that do not fit well in other domains, like Lagrange points and
So presumably
Barycenters.
this thing, as part of the orbital elements, it'll have an orbit center and it says the sun. In
yes,
the case of all these objects.
exactly.
So in principle, we can have orbital elements for exoplanets and stuff like that as well.
We could with the right data. Or for example, we can have orbital elements for moons, and then it will know, oh, this is a moon of Jupiter, so I'm going to have the center at
Yes.
Jupiter.
Well, that's a good thing.
Does the output of orbital elements include the orbit center? I assume it does. Is that
It does not, but we could.
because otherwise, from a given orbital element, how do you know if you're orbiting the Earth or you're orbiting the
I
sun?
think we should include the
Well,
orbit center.
The
by
key
default.
point is the last one, what I call GMASS, which perhaps we want to change the name. That's a multiplication of Newton's constants and the mass of the and the sum of the masses. But of course, the satellite is usually much smaller than the central body.
Yeah, but not if this is orbital elements for Mars or something.
But I mean, once you have that, you can compute anything else. You don't need to know, oh, this was orbiting the sun.
But you need to
That's
know, if you
essentially
want
the
to
mass
know
of
the
the sun.
XYZ coordinates.
Oh, because this is in a reference frame of the ecliptic.
Oh, but what if it's an exoplanet?
I mean, we would need to know data with respect to a given reference frame. So the orbital elements are dependent on a choice of frame.
I see. And so the generic frames may or may not be defined for exoplanets.
Exactly. If somebody has done the proper work of defining correctly a frame and adjusting orbital elements to that frame, then we could follow
Okay, fair
that.
enough. So like we do for geographics, the default is our solar system because that's where everybody who's using the product lives.
Exactly.
Um,
Exactly.
The so far
Yes.
as we know. Okay, GMASS seems very weird. Is that a standard
Yes.
name or?
It's the
How do you
product of G times M. So it's the universal gravitational constant
I know,
times the
yeah.
mass. It's just, yeah.
Yes. How do you call it in entity properties?
I think it's the standard gravitational parameter is what they call it.
Something like
I
that. It's a
think
very long name.
that's the unit name, I think, for it.
Also, another thing we are
Got a
changing.
gravitational parameter. Yeah.
Yes.
I mean, it's not a mass, is it?
No.
Astronomical units cubed divided by days squared is not a mass. That looks very Keplerian.
Right. Exactly. Yes.
I think
Yes.
it should be called gravitational parameter.
Yeah, it needs another name. Totally agree.
Okay. My God, why is that the Laplace Runge lens vector? I thought they were just Runge lens vectors. Laplace get into that picture.
I think I usually take these names from Wikipedia.
I think that's very questionable.
Okay.
I mean, it's usually called the Runge lens vector. I don't know the history of it.
Okay. I mean, something we can easily do is to support both and
Yeah, I
document
know,
one.
but we should do the historical work to figure it out. We should not
Okay.
just believe what some random person put into Wikipedia.
Okay.
I mean, look at textbooks and things, what they call it.
Yes, I've seen both names, and probably even the Wikipedia page uses both names.
Okay, well, I think we should go with what sort of standard textbooks use. I think it's
Okay.
safer. Okay. And presumably, in principle, one can get orbital elements for the galaxy. Like there's a galactic reference frame, isn't there?
There is a galactic reference frame, yes.
And we could get orbital elements for the sun orbiting the central black hole and things.
Yes, we could. Totally.
That would be nice. I'm going to care about that sometime soon.
Okay.
For various reasons.
That gets very complicated though with such large orbits because it's massively perturbed by clouds and things that are disturbances within the galaxy. So
I
it's
understand. So
definitely
it's
not
like
a stable
Well,
orbit.
but this is kind of what is called osculating elements, which is the elements right now at a given point.
Right.
So we don't claim to be able to predict what they are going to be in the future. This is the orbit that if it was Keplerian, then it would follow this orbit.
Right. Right. It's the instantaneous information. And I mean, just, random question here. I mean, we can do it for the center of the galaxy. Presumably, we could do it for the center of mass of the cosmic microwave background as well, in principle. Although maybe none of this applies because it's, too many relativistic issues.
Yes, I think so. That
I mean,
would be more
somewhere
difficult.
you should be able to see that it's, we're going at 10 to the minus 3 C in the direction of wherever we're going. Right? I mean, because that is the instantaneous orbit information on, our position relative to the central mass of the universe.
Yes, though I don't know that it has a Keplerian meaning. So this is some sort of local Keplerian approximation.
Yes. But I think, yeah, I mean, it is surely locally Keplerian just because nothing much is going to change for a while.
Right. It would be mostly strange. It's straight.
Yes. Okay. Another thing I was going to ask is all these diagrams of, how do we make nice solar system diagrams? Like that animation I was showing you of a,
Yes. Yes, we have been working on that, and Jeff has some sort of
Yeah, I've got a
excellent.
WFR called Solar System Plot 3D that currently is only defined to work for solar orbits, but it can plot the orbits of any of our entities that has orbital elements. But it can be expanded to work with orbital elements once it's released.
Right. And you were adding the circles that Stephen was suggesting.
Right. I added support so that it takes labeling. It's using Lisp Point Plot 3D under the hood, so I'm just supporting all the options that it supports, which means I can now customize the callouts, and I can use the circle form for the callouts. Although there's a bug in 3D where the circle isn't quite aligned right, but that's been reported.
Just like geotrajectory, there's presumably going to be an astrotrajectory, and presumably, if you're using astrographics, you can just stick an astrotrajectory into the astrographics.
Yes, I discussed that in the next section, 2 important things to do next, which I now realize I've repeated the first one. Yes, that's what we want to do next. It will take a set of orbital elements or a time series of orbital elements because the orbital elements are changing in time in real applications like TLEs and etc. And then
why are we not talking about an astrotrajectory as well as an astro-orbit?
This is Roger has asked about this multiple times. Yes.
Yes.
To me, they are the
like
same
me.
thing. To me, they are essentially the same thing. It's just to me, any trajectory in space is an orbit, right? Because you are always following the gravitational directions of something else.
Well, depends how fast you're going.
If they're powered,
Yes.
Right. I mean, a thing with a constant ion thruster
right.
won't follow an orbit of a Keplerian, And I would have thought astrotrajectory is a more general concept. You can feed it orbital elements if presumably there's a time series you put into.
I wanted to see a plot, locally of, like the 7,000 Starlink satellites. and their trajectories, their orbits.
Right.
Mhm.
I would have thought astro trajectory is a more general concept.
Me too.
Um, And I think then what it gets is a time series in general. It could either have, look, I think it either has orbital elements, in which case it plots the whole orbit, or it has a time series, in which case it plots just the pieces specified in the time series, would be my guess. But we might end up wanting to have an astro orbit as well as an astro trajectory, where the astro orbit just means the whole orbit, so to speak. Whereas an
I
astro
see.
trajectory means the specific points specified in the time series.
Okay. Okay.
This may be
Um,
related to what you're asking for, but in the orbital elements function, should there be a property called orbit path or something like that? That essentially spits out a line, or does that not make sense?
Sorry, for which function?
Or orbital elements.
Yeah.
Given an orbital elements object, should you be able to ask for, say, orbit path as a property of that and have it give you a line primitive or something that can be thrown into a graphics 3D scene?
Why not? Or a function
mhm.
that gives you the position, as a function of time.
And it's a bit naive because each time around it may do something different. But if we're talking Keplerian, it's going to repeat, right? So
No,
it's
but
going to be
it's an
Yep.
orbital element. I mean, that orbital
Mhm.
element has an orbit that it is
Right.
associated with,
yeah,
which
right.
might just be its extended instantaneous orbit. I mean, it's just like a tangent to a curve is a
Yeah.
line that could be infinitely long, even though obviously the curve won't follow that tangent line.
Right.
Right. Yep. It's
Um,
totally doable.
Okay. VJ on our live stream is asking, can this plot orbits of moons? I think the question is about your WFR, Jeff.
The WFR cannot handle moons. It only handles things around the sun. It's
Okay.
heliocentric orbits only.
But in principle, we can do things.
In principle, it could, but there's a lot of things. Think of that as a very early prototype for an Astrographics 3D or something like it.
I see.
And it
With
would need to be
trajectory.
much more broadened
Okay.
than what we have
This
now.
function can handle moon, but yeah, we need to extend this function.
Is there let's see, the coordinate system that one uses for like moons of Jupiter is basically the solar system barycenter coordinate system. Is that right? In practice, what do people use?
Actually, when you're orbiting other planets, isn't it what planetocentric or planetographic? What is it, Jose? We've
Okay,
asked about that before.
So the idea is to have the third argument of orbital elements to accept frame specifications. By default, it's always going to be the ecliptic frame of the solar system,
Okay.
but which is an inertial frame. But then there is something called the Laplace frame of a body, and so, for example, when you go to NASA pages, they report orbital elements with respect to the Laplace frame of a given body. So there is a transformation to do there. But because we compute this from our ephemerides internally, we can select which frame to use.
Okay. All right. Onward.
Okay. Yeah, completely different. So this is a new type for tabular column.
I think we talked about this already. It's in one.
Exactly. You saw it a month ago.
Yeah. Seems
Okay.
wonderful.
Modulo type setting, because we want to align the plus minuses. This is mostly that.
Do we want to align the plus minuses?
I think so. It looks a bit.
Well, I think we
Like it.
want to align the numbers, however we align the numbers. I mean, numbers, normally numbers would be aligned on a decimal point. That's what I would do. I would not align the plus minus. I would align the decimal point.
Okay.
I would align the numbers however you would align the numbers, and the plus minus is just a little decoration hanging off the end.
I think that would be reasonable. I mean, I think we could do the experiments. I think that if you look at these outer columns, like we take it for granted now, but it's so easy to parse and read these columns of numbers now.
Yes.
Versus
Right. But I mean, so just line it up on its decimal point. I think that will be the right thing. Do whatever you would do if the number didn't have a plus minus, and then let it hang off the end.
I'm sorry, I don't think this can work because different rounds will have different precisions. And so it's not that we are going to have like the same number of digits as it happens with the error columns or the number columns.
No,
so it's
I
not
understand that. I understand.
So some may have a decimal point, others may not have a decimal point.
I know, but there's an alignment of the decimal point that you can use. That would be the way you would. I mean, if you just had those numbers without a rounds, how would they align?
Well, we would align them with the decimal point. I mean, do you actually have the numbers in the first column? It's the same number. So the number and the error, when combined into an around, give that around column. So there, because we show always two
Different numbers
digits,
of digits.
it's very nice to align them. But once we have a round, the error dominates the number of digits.
But I think we shouldn't vary the number of digits. That's exactly what we have avoided. You can't read it very well if
But a round is all about controlling the number of digits from the error. The rule is never show more than 1 or 2 digits of error.
My suggestion is align the decimal points. I think it will look good. Can we do that now here or not?
Not now, but I mean, I have to discuss with Jason.
I think that will be good.
Okay.
I mean, you could try aligning the plus minuses, but I think aligning the decimal points is a much better idea.
Okay, it's like the decimal point if it was there.
Well, yeah, but if it isn't there, you just align one after the decimal point, you know? So in other words, if you've got, well, are any of these whole numbers? They're not.
For example, look at the around column, the around square column. You see some numbers don't have decimal points.
Right, so the decimal point is the virtual decimal point right there, right after the 1. Align relative to that.
Yep. Okay. Okay, so this is just some examples showing that you can do computations with quantities, etc. So geoposition is a type that we had in 14.3. Now we have extended it to accept geoprojections as well.
This, by the way, could be easier to read. I mean, you could align the decimal points or something here. It's a bit weird. It's a bit hard to read.
Yes, I think we are right aligning on the cardinal directions right now.
Yeah,
each individual.
I'm not sure, but that's the right thing.
Okay.
Not obviously wrong, but I'm not sure.
Yeah. So now we can have projected coordinates, and now the type is aware of the datum, the OGV7, a British datum.
Sorry, why does that label right align? Why isn't it centered?
Oh, I think we always do that with numeric kind of columns.
Why did we do that? Why is it always pushed to the right-hand side? Maybe it looks better that way, but I don't remember why.
I don't remember why either.
Yeah, I think
let's ask the rest of the tabular team about that.
Exactly. I mean, typesetting things are not exactly my thing. Okay. With respect to date and time, we have Nick here. Yes, the business calendar has improved a lot in the handling of tabular dates. It's all a lot faster.
Yeah, and a lot of this is being driven by the updated time series project, which I think we're talking about another time. But we've kind of ported over all of those optimizations and changes into the core date and time types as well. Like Jose said, a big focus on business calendars, business days, holidays, etc. But we're many orders of magnitude faster for a lot of operations.
That is a very big speed up.
Absolutely. Yep.
Very nice.
Yeah, I mean, we're dealing with so many dates now. Like what was okay with millisecond timing now needs to be microsecond timing.
Yep.
Or nanos. I mean, some of them were very close to nanosecond time for operations, just because we've totally reworked the internals of how things work.
Good.
Yeah. So this is another table of speed ups, also by several orders of magnitudes.
Wow.
Yeah, the medium is like 1,000, 10,000. Sorry.
Yeah.
Great. Okay.
Okay. So tabular summary. So this is a new function we have added to report about the content of a tabular object rather than the structure. We had tabular structure before, and now we have also tabular summary, which has some graphical outputs and then some statistical outputs by default, but it has many more properties.
So I think the workflow is that when you get fresh data, I think the first thing you're often going to do is to look at tabular structure. For instance, there's a lot of things that probably should be categories that are strings, and that allows you to spot that very quickly. It also allows you to spot things like missing data and other things, which is also probably something you're going to have to pay attention to. Whereas tabular summary gives you kind of a first broad summary of sort of what the values are. You know, if the types are now right, you know, maybe there are even numbers that should have been, you know, strings that should have been numbers. You know, all of that you need to kind of handle it. The tabular cleaning data,
Right.
tabular
So I got a
structure.
few comments here. I mean, first of all, the way this dust works here doesn't work. You need to darken those. You need to
Yes,
make those
it's-
larger and darker somehow.
it's a matter of size. If you can you click on the divider between the categories and the histograms and extend it a bit? There. Exactly. So the points you
Well,
see.
somebody messed up here. We got to figure out how to do this better.
Yeah. So yeah, the points need to be a little bit larger.
So for instance, if something kind of is like comes in as a string, but you see that those levels are like 3, that's a good hint that it probably is a category. But if it's something like an address or a name, you're going to see something that looks like white noise, like kind of the first thing there. That's what I'm saying. There's going to be many, many values.
Yeah.
Right. And so there are ways to specify the columns you want, either by name or by class, like numbers. Then the properties you want. Also, there are families of names of properties. Sorry. And at the end, we have all goes to all, which means all properties for all. So that's all columns. For those columns, give me these properties.
Yeah. Okay. This is nice.
So one can combine various sets of columns, various sets of properties, etc.
I'm about to run out of time, so I need to.
Okay, so let's look at this quickly. So I think you have to run this one because the data is not visible there.
Okay. What
Yes.
are you showing here?
So this is a function that takes existing columns of entities and adds other columns based on properties of those entities. So this is like an easy way to do a combination of transform columns and entity value.
All right, this is a new function, augment columns.
Yes, it's a way to leverage what the entities, you know, the entities contain a bunch of properties, right?
Yes.
And the key value of entities is that it is a key into those other
Right,
properties.
but this name isn't referring to entities here, which is a little weird.
Right.
Right.
So there's a question of, you know, what should we call it? Should it be entity augment or entity augment
Yeah,
entities?
we need to talk about this, but I need
we can do
to
it that,
go.
you know,
Yeah,
that's fine.
we need another meeting here.
Okay.
And this definitely is going to need another meeting.
Right.
Yep.
Okay, we were mostly spending our time in interplanetary space here.
Yes.
Mhm.
But we need to come back down to Earth and look at these other things. All right, I should run. So please schedule another one of these. I mean, I'm sure we'll get the rest of it done in an hour, but let's set that aside.
Okay.
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 All right, see you guys soon.
See you then.
Thanks.